Okay, so I wanted to help you all make a connection between some of the material you learned about earlier related to external validity and what we're focusing on now with statistical validity. So in V12, Prutha explained what the term population means. And so this is ultimately the entire group of individuals which researchers or people conducting a study are interested in. And if these researchers were to sample every single individual within this population, that would be referred to as a census. And so with this example here, we've got 26 people in this circle. And if we were to survey every single one of them and ask them what their gender is, we would see that 15 out of the 26, which is our population size, or 57.7% of this population is female. And so this is a population parameter. However, typically researchers are not capable of conducting a census because it's kind of impossible to survey every single member of a desired population which you were studying. And so this is where a sample comes into play. And so a sample is a random selection of some number of individuals from the population to calculate statistics which are going to represent or are going to be an estimate of what this population parameter is, the desired um, variable we're trying to measure. And so if we see here within our sample, we can see that 3 out of 6 or 50% of the sample is female. And so this is what we would refer to as a point estimate. And so it is 1 point, it is one number, one statistic, and it is an estimate of the population parameter. And so now this is just a simple example of a frequency claim, but we're going to take it a step further in talking about um, this in relation to bivariate correlation. And so to use as an example, we're going to discuss the example used within V16 from the article Orank et al. Uh, wanting to interrogate the association between socioeconomic status and COVID infections, so SES and COVID infections. And so for their study, the population was the entire United States population. But to simplify things, we're going to think about the entire OSU student body as our population. And so at OSU, let's say there's roughly 60, or not three, so 60,000 students. So it's just a rough estimate, right? And obviously, it's impossible to survey every single student at OSU. So we're going to take a sample from this population of 1,000 students, and we're going to ask them what their SES is, their socioeconomic status, or maybe their parents' socioeconomic status. And we're going to ask them about their history with COVID. And so after obtaining the data and conducting or calculating a Pearson's correlation coefficient, we find this R value of negative 0.19. And so now the next question we might ask is, how strong is this relationship? And so first, when looking at our p-value, we can see that our p-value of 0.006 is less than our standard cutoff of 0.05. So we would say that this correlation coefficient here is statistically significant. So now, how strong is this effect size? And so when thinking about the strength of your effect size, like I explained previously, you have to compare it to effect sizes or the standard effect sizes of other studies within your domain of research. And so we'll consider this psychological research. And so for psychology research, an effect size of 0.19 or negative 0.19 is going to be a moderate effect size, whereas an effect size in psychology research of zero point 0.1 would be weak, 0.3 would be strong, and then 0.4 would be like astronomical. Not quite astronomical, but it's not quite common. And so what you can gain from this, or I suppose the next question I ask is how precise is this point estimate? So we know it's significant, but how precise is it? And so to answer that question, we have our confidence interval. And so essentially what a confidence interval is going to give us is a range of values around our point estimate, which we expect the true population parameter to lie. And so ultimately, when we calculate this correlation coefficient, we want to estimate what the true correlation between SES and COVID infection rates are. We want to know what the true parameter is. And so we calculate this estimate. But we need to know how precise that is. And so that's what our confidence interval gives us. And this range is going to tell us that. And so for this example here of negative 0.19, we can see that the range is from negative 0.26 on the high end and negative 0.12 on the low end. And so this range can be said to be, I guess, sort of narrow. And so this estimate would be fairly precise, right? And then just like with our p-value, how we've got a standard of 0.05 for the cutoff, for confidence intervals, we've got a 95% confidence interval. And so essentially what this 95% tells us is that if we were to similarly repeat this survey over and over again, we would expect 95% of those point estimates or correlations calculated from that to lie within this range. And so, as you can see from this confidence interval, being from negative 0.26 to negative 0.12, it does not contain zero, which would indicate a significant effect size or correlation. And so likewise, if this interval were to contain zero, then we would assume that the p-value is non-significant, so greater than 0.05. And so ultimately, like I had said, the width of this confidence interval is going to tell you how precise your estimate is. So if it's more wide, then the estimate is less precise. And if it's more narrow, the estimate is going to be more precise. And so to further illustrate this, we're going to say that we conducted this survey once again. And so we found an R value of negative 0.19, just the same as the original. However, this time we found a p-value of 0.13. And so this p-value of 0.13 is greater than our typical cutoff of 0.05, indicating that this point estimate, this correlation coefficient, is not significant. And so what you can gain from understanding this is an understanding of the confidence interval as well. And so since you know that the point estimate or the correlation coefficient here is non-significant, you can assume that the confidence interval does contain zero. And so as we can see here, we've got our 95% confidence interval. And this range is from negative 0.39 to 0.01. And so you can see that it does in fact contain zero. And so ultimately, I wanted to mention this for y'all since many times you will find that the confidence interval around a point estimate of a correlation is not reported in an empirical article, but the p-values generally are. And it is becoming more and more common for researchers to include confidence intervals, as it is required by some journals. And so, yeah,